Okay, this is Notes 5, and we are doing systems. We're doing linear inequalities. We're not going to tackle systems of inequalities yet. We're just going to do linear inequalities. You need to write the equation in the form of y equals mx plus b, graph the equation, draw a solid line if the inequality is less than or equals or greater than or equals. Draw a dashed line if the inequality is less than or greater than. Okay? Pick a point that is not on the line to use as a test point. The origin actually, 0, 0, is usually good to test if it's not on the line. And we'll talk about that a little bit more. If the point makes the inequality true, then shade that side of the line. If the point does not make the inequality true, then shade the opposite part of the line. So let's get started here. We're going to graph y is less than or equal to 1. Now, hopefully by now, you know that a y is, when you only have y and your number, it is what kind of a line? I hope you're saying horizontal, which means what kind of slope? Yes, 0 slope. I hope you can say that to yourself now, okay? So we're just going to go where y is less than or equal to 1. So we're going to go to where y is 1. And since it's a less than or equal sign, we have a solid line. So I am going to use a solid line here. Okay? And there is my line. Now I have to decide if this equation refers to above the line or below the line, what side of the line it belongs to. So I'm going to use my y is less than or equal to 1. Y is less than or equal to 1. And what I'm going to do is since the origin is not on the line, I'm going to use the point of the origin because it's just easiest to use that. So if I have only a y, I plug in my value that is my y, because this is my x and my y, and I say 0 is less than or equal to 1. Is that true? Well, yes, 0 is less than or equal to 1, so I'm going to include the part with the origin. So I just like to put arrows. It's very easy for me to do. You can shade it. You can indicate it however you would like. Okay? I could have used the point, let's say, 1, 3. Okay? So this is just an example. If I had gone and used the point 1, 3, okay, and I plug that into my y is less than or equal to 1. See, this was true. Okay? I plug in the 3 for y, and it says 3 is less than or equal to 1. Well, that would be a false statement, and that's why this shaded area does not include the point 1, 3, because it's false. Let's try this one. Graph x is greater than negative 2. So this line, what kind of slope is it? Hope you said undefined. Is going to be where x is, you're going to go to the x-axis at negative 2. Since it doesn't have an equal sign, it's a dashed line. So we're going to make a dashed line. And I know sometimes it's kind of hard to tell, but if you make it dark enough and it isn't connecting, then it's pretty easy to see that it is a dashed line. Now, I'm going to do my point 0, 0 because 0, 0 is not on the line to find out what side of this line I'm going to shade. So if I plug x is greater than negative 2. If I plug my x value in for 0 is greater than negative 2. Well, that is a true statement. So therefore, I'm going to shade the side where the origin is. So here it is. So anything on this side of that line would make this statement true. And that's why we shade that side, okay? However you want to do it. Let's flip the page. All right, so now we have y is greater than or equal to 1/2 x plus 3. So first I'm going to pick my y-intercept, which is positive 3. And then it says I've got a rise of 1 and a run of 2. So I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Now that wouldn't give me a very pretty line, so I'm going to go down 1 over 2, down 1 over 2, down 1 over 2. That gives me a much nicer line, and since I have an equal sign, I need to use a solid line. So I'm going to come over here and I'm going to draw my solid line, okay? And I'm going to now do my test to see what side of that line I am going to shade. I'm going to test the point 0, 0 since the origin is not included. And I'm going to say, okay, 0, my value for y is 0, so I'm going to plug it into this right here. And I'm going to rewrite it again just so we're clear about what I'm doing. And I'm going to take my 0, plug it in for y is less than or equal to 1/2 times 0, because that's my x value. Okay, here's my x and my y, plus 3. Well, I get 0 is greater than or equal to, what happens when I do 0 times 1/2? It cancels it out. It becomes 0, right? And I'm going to write this out the long way this time, and then I'm going to stop doing it the long way. And I get, because if you can use the origin, the reason this works so great is it will wipe out this right here and just leave you with your y-intercept. So it's really nice to use 0, 0 when you can, when it's not on the line. So is 0 greater than or equal to 3? No, that's false. So I can't do this side of the line, I have to do this side of the line. So everything over here would satisfy this equation and make it a true statement. Okay? Let's go to number 4. So I've got positive 1 as my y-intercept, and my slope is up 1, 2, 3 over 1, 1, 2, 3 over 1. That's about as far up as I can go, but I can go down here. I'm going to go 1, 2, 3 and over 1, 1, 2, 3 and over 1, 1, 2, 3 and over 1. Ooh, look at that. And it's not going to be a solid line. It's going to be a dashed line. So I'm going to put some dashes in there. Okay. All right. And now I need to do a test. Now, the origin is not included here. If that line was on the origin, then I wouldn't be able to do it. So what I'm going to do is I'm going to go ahead and use my origin as a test. So y is less than 3x plus 1. I'm going to plug in 0 is less than 3 times 0 plus 1. 0 is less than, that makes 0 plus 1. Is 0 less than 1? Yes, it's a true statement. So I can know that everything this side of that line will satisfy the equation and make it, or the inequality, I guess I shouldn't call it an equation, it's an inequality, and be true. Okay? Now, remember the beginning instructions said that your equation, oh, I'm never going to be able to get through this because it's freezing again.